Hello, I'm Jordan Bostic. Today we'll be using the law of cosines. Today's objective is to solve an oblique side angle side triangle using the law of cosines. Before watching this video, you should have some knowledge or work with right triangle trigonometry, Pythagorean theorem, law of sines with side angle, angle, side angle, and side angle oblique triangles, and know that the interior angles of a triangle are supplementary. These are the formulas used when working with the law of cosines. Something you should know is that in these equations, the lowercase letters represents the sides, and the capitalized letters represents the angles. Another thing is that the sides and angles are always opposite of each other. For example, side A is represented by the lowercase letter a. Its corresponding angle will be opposite of it, which is the capitalized letter A. So let's get started with solving for side A. So we're going to substitute all our values into this equation. A squared, we know that side B is 6. Side C has a value of 8. And from this, we're going to put this into our equation. And we know that angle A is 42 degrees because it's opposite of the side A. So we can put, let's go ahead and solve this. A squared equals 6 times 6 squared is 36, or 6 times 6 is 36. A squared is 64. 2 times 6 times 8 is 96. And we're going to keep the cosine of 42 degrees. From this point, we can put this into our calculators, or we can simplify it down further. And we know that 36 plus 64 is 100. We're going to keep the 96 cosine of 42 degrees. Then we can put this into our calculators at this point. When we put this into our calculators, we know that a squared approximately is 28.65. But remember, we're solving for a, so we have to take the square root on both sides to get a by itself. And we know that a is roughly around 5.35. So now we know that the side A is 5.35. So let's go ahead and solve for angle B. We know that side B is 6. We know now that side A is 5.35. C is 8. I'm going to put this right here. And we're solving for angle B. So B is our unknown. 6 squared is 36. 5.35 squared is 28.62. 8 squared is 64. 2 times 5.35 times 8 is 85.6. And we're going to bring down the cosine B. So 28.62 plus 64 is 92.62. And we're going to bring down this 85.6, negative 85.6 in cosine B. In this equation, unlike the other equation where we were able to put the whole equations for our calculators, the negative 85.6 is attached to the cosine B. And remember, we're solving for the angle B. So to isolate this, we have to subtract 92.62 from both sides of the equation. Once we do this, we get negative 56.62 equals negative 85.6 cosine B. Remember, we're trying to isolate B. So to do this, we're going to divide both sides by negative 85.6. And once we do this, we get 0.661 equals cosine of B. We're solving for angle B, so to get B by itself, we have to take the inverse of cosine on both sides of the equation. And we can do this by putting this into our calculators. And so we know that the value of angle B is approximately 48.62 degrees. So now we know the angle measure of B and the angle measure of A. Every triangle has an interior angle measure of 180 degrees. From this, we can use this formula A plus B plus C equals 180 degrees to solve for C. So we know that angle A is 42 degrees. Angle B is 48.6 degrees. C is unknown, and we know this will always equal 180 degrees. 42 plus 48.6 is 90.6 plus C equals 180, because remember we're solving for C to get the value of angle C. And to this, we're going to subtract 90.6 to get C by itself. We get C equals 89.4. We can always check our answer again by just putting this back into the formula. 42 plus 48.6 plus 89.4. Once we put this in our calculators, we know that that's 180 degrees. So today we just solved a side angle side triangle using law of cosines. We found the missing side A and the missing angles B and C.